Welcome to this explainer. Today, we're popping the hood on the ultimate machine, the human body. Whether you're an elite athlete chasing a gold medal, or honestly just someone walking down the street, have you ever stopped to wonder what exactly is driving your physical actions? Today, we're exploring the hidden internal engines of human movement. We're going to break down exactly how your body coordinates action, and it is absolutely fascinating. So, let's dive right into this. How exactly does the human body create explosive dynamic movement without, just tearing itself apart? It's a pretty serious biological puzzle. Think about it. If all your muscles fired at maximum capacity at the exact same time, you'd literally be paralyzed with tension. You wouldn't be able to move a single inch. Instead, smooth, coordinated movement requires an incredibly precise system of checks and balances. Here's our roadmap for today. First, we'll look at the push and pull principle. Second, upper body, lifts and strokes. Third, lower body, sprints and jumps. And finally, optimizing your human machine. Let's get right into it.
Section 1, the push and pull principle.
To really get how we move so seamlessly through the world, we have to look at what is essentially a highly coordinated biological game of tug-of-war. We're talking about antagonistic muscle pairs. These are pairs of muscles in the body that have completely opposing actions. The absolute secret to movement is in their teamwork. When one muscle contracts tightly, its counterpart relaxes smoothly to actually allow movement in that direction. This continuous, harmonious exchange of tension and release is the foundation for literally everything, from taking a leisurely stroll to Olympic powerlifting.
Moving to Section 2, upper body, lifts and strokes.
Let's take this push and pull principle and actually see it in action. We'll start by looking at the upper body, analyzing the vital anatomical pairs responsible for our arm and chest movements. Here is our very first opposing pair. You've got the biceps. Located right there on the front of the upper arm, this muscle is responsible for flexing the elbow joint. Opposing them, we have the triceps. Situated on the back of the upper arm, these muscles do the exact opposite. They extend the elbow joint. One bends, the other straightens. Think about how this works in a real-world exercise, like a classic weightlifting bicep curl. In step 1, the lifting phase, those biceps contract powerfully to pull the weight up. But for that to happen, the triceps have to deliberately relax to allow that upward movement. Then, watch what happens in step 2. During the lowering phase, muscle dominance beautifully switches to fight gravity. Now, the triceps actively contract to straighten the arm with control, while the biceps take their turn to just relax. Now, what's really interesting is when we move to the torso. It's fascinating how these two massive, powerful muscles oppose each other around the shoulder joint. The pectoralis major, your main chest muscle, flexes, adducts, and internally rotates the shoulder. Meanwhile, its antagonist, the latissimus dorsi, located in your back, extends, adducts, and internally rotates that exact same joint. It is just a fantastic anatomical rivalry. Picture a swimmer slicing through the water, executing a powerful freestyle stroke. This whole dynamic movement relies entirely on this chest and back pairing. In step 1, during the pull phase of the stroke, the latissimus dorsi contracts heavily to pull the arm backward, giving you extension and adduction, while the pectoralis major relaxes. Then, in step 2, the recovery phase, the roles flip completely. The pectoralis major fires up and contracts to pull the swimmer's arm forward again, while the latissimus dorsi relaxes. It's a rhythmic, continuous exchange of aquatic power. All right, section 3, lower body, sprints and jumps. Now that we've mastered the mechanical engines of the upper half, let's look at where we generate some massive, heavy-duty force for locomotion. Notice the stark contrast between these huge leg muscles. The hamstrings, located on the back of the thigh, are engineered to flex the knee joint and extend the hip joint. Conversely, the quadriceps, positioned at the front of the thigh, do the exact reverse. They extend the knee and flex the hip. They literally mirror each other's functions perfectly across two incredibly critical joints. Let's see how this builds into running mechanics. Every single time you take a stride, you cycle through these phases. Step 1 is the push-off phase. Your quads contract intensely to straighten the knee, propelling you forward, while the hamstrings relax to let it happen. Instantly, in step 2, the swing phase, the hamstrings contract to bend the knee and bring the leg up for the next stride, while the quads let go. It's a rapid-fire engine of contraction and relaxation happening in a split second. Moving slightly further up the legs, we find the primary pair controlling the hip joint's final ability to open and close. The gluteals, your glutes, are built to powerfully extend the hip joint. Opposing them at the front are the hip flexors. Found, naturally, at the front of the hip, their entire purpose is to flex that joint. What's wild is how entirely different athletic movements demand dominance from completely different halves of the specific pairing. Consider these two track events. In sprinting, the hip flexors take the spotlight, contracting rapidly to snap the thigh forward for maximum speed while the glutes relax. But switch your visualization to hurdling. Launching your entire body over an obstacle requires the glutes to contract heavily to forcefully extend the hip, while the hip flexors must immediately yield and relax. Finally, let's bring our focus all the way down to the lower leg, highlighting the everyday tug-of-war happening at your ankle joint. The gastrocnemius, your main calf muscle, plantar flexes the ankle. In simple terms, it points your toes downward. Its direct antagonist is the tibialis anterior, the muscle on your front shin. It dorsiflexes the ankle, meaning it lifts the foot upward. Think about how you use your feet every single day. These opposing actions govern it all. When you're running or jumping, that explosive push-off from the ground happens because the gastrocnemius contracts to point the toes downward, while the tibialis anterior relaxes. But for something as completely routine as walking, the tibialis anterior must constantly contract to lift the foot, that's dorsiflexion, so you clear the ground during your stride, while the calf muscle relaxes.
And that brings us to section 4, optimizing your human machine.
So the crucial point is, why does all this anatomy actually matter to you? We've learned the biology, but let's shift focus to practical athletic application. We've distilled all these facts into this comprehensive cheat sheet right here. We have our 5 pairs, the biceps and triceps controlling the elbow for lifts, hamstrings and quads manipulating the knee and hip and running, gluteals and hip flexors mastering the hip for sprints and hurdles, gastrocnemius and tibialis anterior operating the ankle, and the pecs and lats driving the shoulder in swimming. This table is basically your master blueprint for how human movement works. Understanding the dynamics of these antagonistic pairs is an absolute game changer. This knowledge is the key to 3 major things: optimizing your athletic performance, preventing devastating sports injuries, and improving your overall movement efficiency in whatever activity you do. When you deeply understand which internal engine should be firing and which should be chilling out, you train smarter, move better, and keep your body safe. I'll leave you with this final, provocative thought. The next time you take a simple step, which of your internal engines are quietly contracting and which are letting go? Your body is a true masterclass in biomechanical engineering, a perfectly balanced machine where every single push requires a beautifully coordinated pull. Thanks for joining me on this explainer today, and keep exploring the amazing mechanics driving your every move.